Let us grow our knowledge and skill sets on vertical projectile motion by looking at question 3 of the November 2016 final examination question paper. Now, to do this question, we always use the academic constitution when we solve physics problems. And perhaps the first step that we are going to take is interpretation of the problem. Now, to do that, I'll read the problem, write down the given information, choose direction, and put stuff on the diagram that I have, the quantities and the vectors that I have there, so that the question makes sense. Remember, this is a physical problem. It's something that we can observe or at least imagine in our mind. The question reads as follows. It says that a ball is dropped from the top of a building 20 meters high. Ignore the effects of air resistance. The first thing that I'm going to do when I interpret this problem really is to choose direction, to say any vector that goes upwards, I will take it to be positive. Now, when we look at our diagram, we are saying that the ball is dropped. We know from our lessons of vertical projectile motion that when we use the word dropped, it means that the initial velocity of the projectile is actually 0 meters per second. It starts stationary when it starts moving. And the other thing that is interesting here is that we are saying that our ball will move from here and come down there. That means it will have a vector that moves from here to the ground, and that vector is the displacement. And because it's a vector that goes downwards, do you see that this vector goes down? When the ball gets here, it will have covered this displacement of 20 because, it's the height of the building. It means my 20 here is going to be negative 20 meters because it's a vector that goes exactly in the opposite direction of what I chose. The up is positive and it's going downwards. And we were further told that we should ignore air resistance. That means there is no forces that are caused by air friction. There are no any other external forces. The only force that is present in this situation is the force of gravity. And we all know that that force points vertically downwards and it produces an acceleration that also goes downwards. And that acceleration will be defined by a vector that goes vertically downwards. And this would be A is equals to G, because we call it G, this acceleration, which will then be given by negative 9.8 meters per second squared. Also, again, it's negative because it's a vector that goes in the negative direction. Now, I'm done with interpreting my problem. What I will do at this stage is that I will classify this problem as a problem that requires the use and the knowledge of a vertical projectile motion. That means we're going to use equations of a VPN to solve any calculations, and we might be required as well to draw graphs, vertical projectile motion graphs, because we already done that as well. So that's how I'll classify this problem. It is possible to classify this problem to be linked to other topics of physics, but for purposes of this question, I'm only going to stick with VPM when I solve this problem. Now I'm ready to answer the questions. That means the third step that I'll take is to answer the questions. Question 3.1 says to us that define the term free fall. So we are doing question 3 and we are on 3.1. So we'll say that free fall can be defined as the motion in which an object is moving, under the influence of gravity alone. I mean, when there is no air resistance, an object basically will move under the influence of gravity alone. Now, this type of a question, we call it a concept question. It's a question that focuses on concepts. So it requires you to apply what you have studied. So now, when you have written an answer like this for this concept question, the final step and last step that you need to do here is to navigate the answer, what we call an navigating the answer. In other words, you look at your answer and check if there's any spelling errors, if your sentence is well constructed, and you fix that before you move to the next question. And by doing so, you actually ensure that you take the maximum marks of 2 for this question, because you'll have rectified everything and you'll be happy with everything. And all this should be done within 2 minutes, because 2 marks means 2 minutes. You should spend 2 minutes to do that. Very easy if you have studied. Then we are ready to then jump to question 3.2, which then says calculate 3.2, and then under 3.2.1, they say the speed at which the ball hits the ground. Now remember that this ball will have a trajectory that is vertically downwards here, and then it will get to this point. Just before it hits the ground here, we are actually looking at that speed. I'll call it final speed, because I mean the initial speed is when it starts with 0 there. And at first glance, you can already see that we have 4 quantities here. We have 3 quantities, not 4. I have the acceleration, the initial velocity, and the height. And obviously, when we have 3 quantities, we can use any of our equations of motion. That requires to know only 3 things. So now, to solve this problem, we are going to choose the equation final velocity squared is equals to initial velocity squared plus twice the acceleration times change in y. Now from here, this question becomes a simple substitution problem, where we're going to say the initial velocity is 0, because this object really starts by being dropped. Then we also have 2 times negative 9.8, because remember we said the a here is the same as g and is given by 9.8. And the ball is displaced in the negative direction, as I have explained here, that it is displaced in that negative direction. It's a vector that goes in the negative direction. Now, the next step that I'm going to do here would be to remove this square here by putting a square root on both sides, in which case I'll then now have 2 times negative 9.8 times negative 20. Remember, this is just 0, it can be removed. Now I can use my calculator here now to say 2 times negative 9.8 times negative 20. And that gives me a final velocity of, remember here when you put the square, you have plus or minus. So this means here our final velocity would be 19.7. Okay, because the 8 will throw in a 1 at the 9, so that it becomes 10. That 10 will throw a 1 at the 7. So we have here, we are going to have here 80 meters per second. Now, obviously, we know that our vector here should be a negative vector. We should get a negative 19.80 meters per second. But because the question says to us we should calculate the speed, it means we are only going to write the number without the negative there. Because speed is only the magnitude of the velocity. Now, already what I was doing here, because this now is a second type of question that you will get in physical science or physics, which is a calculation problem. So when you have done a calculation problem, you have to look at your answer to see if there's no errors as well. If you calculated the correct variable, which is the final velocity here, so it's correct, and I've written the number and the SI unit as well. And also because this is speed, I didn't attach direction, very important to ensure that we get the full marks here. And those marks will actually come to be using this formula, substituting 0 here and substituting this 2 and actually writing your final answer. That will give you the 4 marks. This number as well looks pretty good for me, given that if you look at this object, it moves for 20 meters. That's quite a lengthy distance, so it will be increasing. Remember, it starts at 0, it will be increasing its velocity as it goes down. So at this stage, we expect to have such a velocity or speed of almost 20 meters per second. Not so alarming, it's not too small, it's not too big as well. Now I'm ready to then answer question 3.2.2, which requires us to calculate the time it takes the ball to reach the ground. So what we want here is actually the time, to say as it moves downwards like that, what is the time? What time does it take to go down? We can also call this T total, to say the total time that the ball is in motion, because after there's no motion. Maybe it stops, or we don't consider that motion after past that point. Again, if you look at this question, we have a lot of variables at this stage, because we have G, we have the acceleration. We also calculated this, we said this is so this is going to be negative, because as a velocity, as a vector, is negative, right? Then we also have here this, so we have about 4 quantities. That means I can use almost all of my equations of motion really to solve this problem. I am going to choose the equation that comes from the definition of acceleration, which says the final velocity is equal to the initial velocity, the acceleration times time. And remember, this time here, I said it's like the total time that the ball is in motion. We know that the final velocity will be negative 19.80. Remember, it is this vector here. So this number here will be negative when the ball gets at the bottom, because the vector pointing towards the downward direction. And the initial velocity is 0 really. And here we are going to have the negative 9.8, and we have the change in time. Now, because this is 0 here, I'm just going to divide by negative 9.8 on both sides. Negative 9.8 on both sides, so that this side it cancels, and I'm only left with the change in t here. So I'm going to punch this on a calculator. Now this means here we're going to have change in t is equals to, now we are going to have here negative 19.80 divided by negative 9.8, and that gives us a time of 2.02 seconds, around about 2 seconds to get to the ground. Now there is another way of solving this problem, and I really want to talk about this method. I think it's very important to make this point. I've talked about it in the previous questions that we've done of vertical projectile motion, the November question papers, the 2014 and 2015, to say you can use this equation to solve this problem. And with this equation, you would see that our displacement will be negative 20, because this ball goes in the negative direction, the vector goes in the negative direction there, and it starts with an initial velocity of 0. That means the whole thing here becomes 0. And here we have 1 over 2 times negative 9.8, and we try to calculate the time. I'll stop here because I want you to finish calculating this and see if you get the same answer that we did there. However, I want to make this important at this stage of the question, to say that I would advise that in an exam you always choose this equation when you have a problem that is like this. The reason being is that when you compare these two equations, you can see that here on the first one, we're using the negative 19.80 to find our answer. But the 19.80 is a number that we calculated from the previous question. That means if we were not getting a correct answer from the previous question, if we made an error, or this question maybe we didn't get the correct answer, we will continue with a wrong answer here. And that would translate to the fact that we are risking to lose full marks. Even if they can do positive marking, you are not going to get full marks. Now, the advice is that you use this equation, because on this equation, all these numbers there, 20, negative 20, the 0, the 9.8, we didn't calculate. They were actually given in the problem. We have the negative 20 here, we have the 0, we have the 9.8. So that means if we have done a mistake here, at least we have a chance in this question to get the full marks. So it is highly advisable to use an equation that uses original given data instead of using the calculated data. Unless it is not possible for you to do so, then you can use what you calculated in the problem. Because we are practicing, I use any method here, because we also need to learn to be flexible, to be comfortable using these equations. Now, I will move to the next question, but firstly, let us look at how we are going to get here the 3 marks. I mean, this was not really a tough question. It's just, that substitution and the final answer that gives you 3 marks. Now, question 3.3 says, sketch a velocity versus time graph for the motion of the ball. And they further say here that no values required. And you can see even here that this is only for 2 marks. Because usually this will be marked out of 4 to 5 marks when we start putting in the values that we calculated as well. But besides, this is a very simple graph to draw, because, it is an object that is thrown vertically downwards. So I'll start first by writing my title for the graph to say this is a velocity versus time graph. Very important to write your title. And I'll draw my set of axes on this one to draw the graph here. So this is time in seconds, this is the velocity in meters per second, and we know that this is the origin. That's why the velocity and the time are both 0. Now, we spoke about this extensively to say when we draw the velocity versus time graphs, we actually use this equation to draw the graph. This is a straight line equation. Y is equal to mx plus c. And the first thing that we note from this equation really is that the acceleration, which is the gradient, is negative. And we know that a straight line that has a negative gradient will go downhill. It will be a line that goes like that. And we know that the initial velocity here, v, stands for the y-intercept. That's where our graph will cut the y-intercept, meaning that's where the time is 0. And we in this case, because the ball is dropped, we can see that it actually will start at 0. So that means this point here should be 0 meters per second. Right, so I'm going to simply take this graph and put it on the Cartesian plane. So we're saying it should cut the y-axis here, and then it's a graph that goes downhill. So it's a simple graph that goes like that. So it cuts this point here, and it goes downward like that. So this means the ball started at the initial velocity of 0, and it was going in the negative direction. It had negative velocities, meaning the velocities here, these velocities were pointing in the negative direction as it goes down, and they were increasing because it started at 0, and it goes to 19.80. They're increasing. until we get to that point of 19.0. Now, because the question said to us that we should not put any values, no values required. So this means you can put them, you may not put them, they don't care. They're not going to mark if you put them. So you can leave your graph like this, in which case it will give you the 2 marks because they'll mark the shape of the graph, and they will also mark the fact that it starts at the correct initial velocity. Otherwise, if you like, and for practice purposes, we can really take this further by just putting the values to say this ball will actually move downwards to negative velocities until it gets to a velocity here of negative 19.80. This is when it is here at the ground, and the time it takes to do that is actually really the 2.20 seconds. So it will be the time here. This is the total time. This is 2.02 seconds. It's when the motion will end. It's when the ball is here. Remember, we said this is the time when the ball reaches this point. If you like, you can put those values, but in this case, they're not going to mark them. Normally, it will be 1 mark for that and 1 mark for that and giving you 4 marks. But for this one, they just kept it at